All right, have a little animation. I think sometimes animations make all the difference in understanding what's going on. But they took a circle, and the circle has a diameter of 1, so they decided to give you an idea of what 4 of those circles would look like side by side. And it turns out that when we unwrap that circle, it takes just a little bit more than 3 to unwrap it. The circumference of that circle, when its diameter is 1, happens to be pi. Okay? If it had had a diameter of 2, right, then the radius would have been 1, and we would have had basically 8.26 across. All right, so we're going to look at some animations and things like that to help us understand where we're going with this stuff. If you want, color is a good thing. So if you don't have colored pencils out and you want to borrow some or some markers, you feel free to do so. So today we're going to talk about angles. And those angles have 3 parts to them. They have a vertex. That's the most common thing that we're interested in and worried about, is the vertex of an angle. But it also has 2 rays. They will be. Yep, absolutely. So we will have 2 rays, and those rays have a common vertex. Okay? The initial ray is the beginning of the ray, and I denoted that one in green. And the terminal ray is the ending ray, and it's denoted in red. So when we want to talk about the measurement of an angle, we want to know how far is it from our initial side to our terminal side. So far, so good? Initial means start, terminal means end, green means go, red means stop. All right, so when we put that angle in standard position, it means that our initial ray or our initial side has to be the positive x-axis. Okay, we put it in a coordinate plane, and the initial side is your positive x-axis, and your terminal ray is somewhere else. Could also be the positive x-axis for that matter. But we rotate it so that that initial ray has to be the positive x-axis. And then we talk about what is the measure of this angle. So far, so good? All right. So when we measure the angle from the initial ray of the positive x-axis to the angle, and we go in a counterclockwise direction, then we are using a positive measure. From the initial ray of the positive x-axis counterclockwise, that's a positive angle. From the initial ray to the terminal ray clockwise is a negative angle, negative measure. Okay? So we have 2 angles here. This particular angle has a positive measure because we went from the positive x-axis to the terminal ray in a counterclockwise direction. This particular angle has a negative measure because we went from the initial ray to the terminal ray in a clockwise fashion. So far, so good? Okay, so we have the ability to name angles a couple of different ways. I could say, hey, what's the positive measure of this particular angle? And what's the negative measure of that same angle? Okay, going from the initial ray clockwise gives me the negative measure. Likewise, I could say, what's the negative measure of this one? Or I could have started from the initial ray and gone in a counterclockwise fashion and gotten a positive measure for that angle. So far, so good? Okay. So, what is a degree? Well, when we talk about a circle, we say that it has how many degrees? 360. 360 is a full rotation, a full revolution, a full circle. So why did they choose to make 360 different parts be the measures of it? I'm not sure. I should have researched it for you. But when we want to talk about 1 degree, then it's 1/360th of a revolution. And 1 degree is so teeny tiny that it's very difficult to see it on a small sheet of paper, right? So I expanded it across here and to show you what that opening is. Now, degrees are great, but they're not even accurate enough. 360 isn't enough when you talk about navigation, and we'll talk about that tomorrow. But in navigation, a global navigation type of thing, you'd be a long ways off if you could only deal with degrees, okay? Because the globe is so very, very big. Think of how far those 2 points are apart on this paper. Now think about how far they would be apart if you're talking about 50 miles, okay, or 1,000 miles. Make sense? All right, so degree is 1/360th of a whole circle, or of a whole rotation. So we want to talk about coterminal angles. What does the prefix co mean? Together. Yep, two together. So together. Terminal means ending. Okay, so we want to know what are 2 ways that we can talk about this same angle that has this initial ray and this terminal ray. What are 2 ways that we can name it? What are coterminal angles? What are angles that have that same terminal ray in standard position? So we can measure this one way, the counterclockwise method, to get a positive angle, and we can measure it the clockwise method to get a negative angle. So far so good? Ends up in the same ending place. Or we could say, guess what? I could still use that same positive angle by going counterclockwise, but I could also say, wait a minute, I'm not going to stop here. I'm going to keep going and give it a revolution plus that initial angle to get to the same place. Or 2 revolutions, or 3 revolutions, or 4 revolutions, right? So they can all give you the same coterminal angle. So let's put that into practice. We want to find a coterminal angle, 2 coterminal angles, one positive, one negative, for 30 degrees. Okay, so let's visualize this. If we put in our axis, I want to start with black. All right, so let's go with a positive y, or y-axis, x-axis, and here's our initial ray, our initial side. Where's 30 degrees at? A little less than half. 45 would be half of 90, right? So a little bit less than half. So something like that would be a 30-degree angle. So that's its positive measure because I started at the initial axis and went in the counterclockwise direction. What would be its negative value? Negative 330. How did you get that? Okay, so negative 330 means that we took the 30 and we subtracted 360 from it. Okay? Well, that's a negative value. We also need to find one positive one. So what would we have to do? Add 360. If I went 30 plus another 360 more, I'll end up in the same place, coterminal with it. So 30 plus 360 gets us 390. All 3 are coterminal angles. Make sense? Okay. 135. What does 135 look like? Initial ray is the positive x-axis. Where's my terminal ray? Halfway between in the second quadrant. So this is 135 degrees. Okay. So how would we find the negative equivalent to it? The negative coterminal angle. Subtract 360. And we get negative 225. So negative 225 means that we went in a clockwise fashion, 225 degrees. Okay, coterminal. How can we get another positive one? Add 360. Add a full revolution. They're going to have the same terminal ray or the same terminal side. And we get 495. From here, keep going. A whole circle plus 135 is 495. Easy peasy? All right. Well, you remember that from last year. It doesn't hurt to make sure we've got that foundation. So now we want to talk about our unit circle. Okay? So our unit circle was a tool that we used last year to help us remember some very special angles. Okay? Those special angles are used all the time in architecture, construction, and engineering, and it's because they come from two very special triangles. What kind of triangle is this? A right triangle, and even more specific than a right triangle, isosceles. Okay, an isosceles right triangle. In other words, it's a 45, 45, 90 triangle. Since there's 180 degrees in a triangle, 90 is used up and these have to be equal. They're each 45. So we like to know special measures of 45-degree angles. Okay, we want to have them memorized at the tip of our tongue immediate, okay, by the time this chapter's over. The other one that's special is this particular triangle. What kind of triangle is that? Equilateral. And the cool thing about equilateral is that we can also get a right triangle from it by bisecting one of those 60-degree angles, and it becomes perpendicular to the base, and we end up with a 30, 60, 90 triangle. Okay? So we want to know our 30s, our 45s, our 60s, our 90s, those kinds of angles. Make sense? All right, so I specifically gave you some lines in there. Your lines are, you actually have more lines than I do, okay? You have lines that look like this. I'm not doing a good job with those lines, am I? So I should have drawn this, or given you the same one that I had, or vice versa. Let's try that again. All right, so how many, actually, okay, I think we're getting close. It looks something like that, right? But also down below, okay? So in order to have your unit circle be ready to be built, we want to mention all of the angle measures kind of in the central up part of the circle. And then we're going to go in degrees. We're going to go in and do radians as well. And then we want to leave some space on the outside. Eventually we're going to put in our coordinates for our unit circle. Okay? So how many degrees is this broken up into? Every 15. So you don't want to do the first one. You want to do the second one where my red dot is. And how many degrees is 15 plus 15? So that first one's a 30-degree angle. Actually the second one, but the first one we're interested in. Okay, what's 15 degrees more than 30? 45. So my blue dot corresponds to 45-degree angle. And the green, 60 is 15 more than 45. And then we don't need the next 15, so we need the one after that, which is 60 plus 30 is 90. So we're going to write it 90 degrees here. Okay, then we skip one, and the next one's going to be, add not 15 but 30 on, and we get 120. Add another 15 on, we're at, and another 15 gets us, we skip the next one, and our quadrantal angle is 180. Okay. We add not 15 but 30 onto 180, and we're at, and then we add another 15 onto 210, and we're at, and another 15 onto 225. And 30 onto that 240, 270. $270 plus 30 is 300 plus another 15. 315 plus 15. And suddenly when we're back to the very beginning, we're at, which is the same thing as 0 degrees. So far so good. Coming back to you. You guys used the unit circle well last year, right? Okay. All right. So next we want to talk about radian measure. So if we start with a radius r for any circle, and we take that radius and we mark it off along this, make a sector basically, marking it off along the outer edge of, or this doesn't have an edge, but around the outside of the circle, we get 1 radian, 2 radians, 3 radians, and just a touch more, 3.14 radians, 3.141569, etc., pi radians. So how many radians in a whole circle? 2 pi. Okay. It helps to see it one more time. So we started out with a point, and we drew out a radius, some random radius, it doesn't matter how big it is, and we take that radius and we wrap it around the circle. It wraps around there 1 time, 2 times, 3 times, pi times for the semicircle. So altogether 6.28 whatever it is radians for the whole circle, 2 pi radians. Okay. So we talk about radian measure being equal to, or actually theta being equal to s over r, where s is your arc length and r is your radius. So if we know what our arc length is and what our radius is, we can find out what central angle we have. And if we know our angle and our arc length, we can figure out what the radius is, and so on. So theta equals s divided by r is our formula that we can use to find the radian measure of an angle in a circle. And we'll use that later. Okay. All right, so here was our circle. Oops. Unit circle. Okay. Let's go in and put the radian measures in there. Okay, now radians are kind of nice. You're going to prefer them over degrees once you get your mind wrapped around it. Okay, and I'll explain why in just a second. So when we're looking at this circle, do you want to work with the red dots, the blue dots, or the green dots first? Green? All right, so green. That means that we have split this pi radians, right? up into how many equal parts? 3. Okay? So this one is 1/3 of that whole pi, or pi over 3. The next one is 2/3 of pi, or 2 pi over 3. And the third one is pi, 3 pi over 3, which is pi. Write that one in black. So you're going to do these at the same place with your degrees, and then again, we're going to do the same thing with radians. Okay? So pi over 3, 2 pi over 3, 3 pi over 3. What's this one going to be? 4 pi over 3. Do that one in green again. And what's this one going to be? 5 pi over 3. And finally, we're back here to 6 pi over 3, which is 2 pi. Or 0. Okay. All right, which one do we want to work with next? Blue or red? Red. Okay. So red says, I've now split this up into, guess what? This green's kind of like a red. To make this work, I've got to split it up this way to be even. They all equal parts now? Okay. So how many parts do I have? 6. So how much of the pi is this one? 1/6. 1/6 pi, or pi over 6. Okay, my next red line is 2 pi over 6, right? Which reduces to pi over 3. My next red line is 3 pi over 6, which reduces to pi over 2. Okay, my next one is 4 pi over 6, which reduces to 2 pi over 3. How many pi's over 6 here? 5 pi over 6. And how many pi over 6 is here? 6 pi over 6. 6 pi over 6 is the same thing as pi. Okay, how about the next one? 7 pi over 6. Then the green's also a special 30, right? 8 pi over 6. 9 pi over 6, which reduces to, yep. So we're at 9 pi over 6. Guess what? Here's a 10 pi over 6, right? Which reduced to 5 pi over 3. And this one's going to be 11 pi over 6 and 12 pi over 6. So we're just counting. Okay. Now let's do blues. Okay. We're splitting this circle up into blues. I have to have a blue there, one there, one there, one there. So how many did I split that pi up into? 4. So now we're going to count by 4s, right? Or by fourths. This one's going to be pi over 4, or 1/4 pi. This one's going to be 2 pi over 4, or pi over 2. Then 3 pi over 4. 4 pi over 4, which is pi. 5 pi over 4. 6 pi over 4, or 3 pi over 2. 7 pi over 4, 8 pi over 4, 2 pi. Now the reason the radians are going to be beneficial to you is you really don't have to think about them a whole lot, because if it has a 6 in the denominator, what kind of angle is it? A multiple of 30 degrees. Okay, one of the 30-degree angles. If it has a 4 in the denominator, it's a 45-degree angle. If it has a 3 in the denominator, it's a 60-degree multiple of some sort. Okay, so that's going to be helpful to us later. You're going to prefer to be in radians, whether you believe it or not. Okay, questions on this? All right, so if I gave you a quiz tomorrow, for your benefit only, not graded, do you think you could go through and label your unit circle? Okay, with practice, right? We just need practice. So you may not be able to do it tomorrow right away. That's okay. We won't necessarily be assessing it for a grade, but both radians and degrees. Okay, that's our first goal. Be able to easily, quickly put in radians and degrees so we're not lost. Okay, then we'll start putting measurements with it. Yes, sir? I would keep maybe your notes, but the assignments themselves, the papers, you won't need. Okay, because we're building on 3 different new concepts. We're going into the trig part of things. Good question. Okay, next piece. Here we go. So now we want coterminal angles for the given angle. Okay, what did we do when we were in degrees? Added and subtracted 360. So what are we going to add and subtract if we're in radians? 2 pi. Okay, so when we want coterminal angles and they're in radians, we want to keep it in radians, we're going to add and subtract 2 pi. Okay, now let's think about where our 7 pi over 4 was. I think I'm a visual person, and it's better for me at least to see it from a visual standpoint. Let's count by pi's over 4. A 4 is a 45. Every 45 we're going to have a dot. So here's 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. That's my terminal side. So I went 7 pi over 4 in a positive counterclockwise direction, and there I am. Make sense? So what would this be in a counterclockwise direction? Sorry, in a clockwise direction. Negative pi over 4. Why? Well, what is 7 pi over 4 minus 2 pi? 7 pi over 4 minus 8 pi over 4 is a negative pi over 4. We had to get a common denominator, right? Okay, so that's our negative one. How do we find the positive one? Yeah, let's add a whole circle, whole revolution. We went all the way around, but not that far, or actually not that far, plus more. Okay, so we're going to take that 7 pi over 4 and add a 2 pi, which is the same thing as 8 pi over 4, which adds up to 15 pi over 4. So if it's in degrees, leave it in degrees unless they tell you otherwise. If it's in radians, I want the answer in radians. And of course, we could have added another 2 pi and another 2 pi and another 2 pi, right? And they'd still be the right answers. Okay, 5 pi over 6. What are we doing? Yep, adding and subtracting 12 pi over 6. Okay, assignments on the blog. It's also right here. So take a quick photo and away we go.